Okay, so let's talk a bit about isotopes and stability. Isotopes all have the same number of protons. If I have an atom, it will have a certain number of protons. But if I have different types of atoms, the things that can make them different are the number of neutrons. So let's talk about carbon. It's a good example because there are a lot of different isotopes. Now, carbon-12, which we've already seen, has 6 neutrons and 6 protons. I'm going to call a proton an E+. So let's get used to this. Proton is E+, and then neutron is N0. That'll be the notation that I use. Um, so I have these other isotopes of carbon that have different numbers of neutrons. So for example, here, carbon 8, it still has 6 protons. It has 6 protons, and it has, well, 2 neutrons. Our carbon-22 has 6 protons, and, well, how many neutrons does it have? 22 minus 6, what is that? 16, and 16 neutrons. So I can figure out how many neutrons it has. Hydrogen is another good example. You have hydrogen, you have deuterium, which is still hydrogen, it's an isotope of hydrogen, and tritium, but they have differing numbers of neutrons. So H2 has 1 neutron, this has 2 neutrons, and by the way, H1 has 0 neutrons. Molecules and atoms can be unstable because of their electron configuration. In these cases, the electrons change to find a more stable configuration. So let me give you an example. If I have a nucleus and I have these shells, the electron would be here. It would be in that that lowest shell. But if the same atom, where I just have 1 proton, then I have these shells, let's say instead of the electron being in the innermost shell, that the electron is in that shell. That atom is now unstable because that electron is going to tend to fall down to that lower energy state. And so it's unstable. The electrons would change to find that more stable configuration. However, nuclear stability is not the same. An unstable nucleus will emit radiation to find a more stable configuration. Usually, they are unstable because the nucleus is too large. By the way, I mean, this is true for electrons too, that they'll emit radiation when they move to a lower energy level. So that part of it is the same, that an unstable atom, when the electron moves from a higher energy state to a lower energy state, will emit a photon, a piece of light, radiation, to find that more stable configuration. But usually, these nuclei are unstable because the nucleus is too large. So the strong nuclear force, remember if it's too large, the strong nuclear force only acts over like 10 to the minus 15 meters. And if it gets too big, then the strong nuclear force cannot hold the nucleons together. Now, all nuclei with Z greater than 82, and lead has Z equal to 82. So all nuclei that are bigger than lead are unstable. Those are radioactive elements. For A less than 40, the stable nuclei have about the same number of protons and neutrons. So you can have stable so for stable nuclei, they have about the same number of protons and neutrons. So you can have nuclei that are unstable with a Z less than 82, but they typically do not have the same number of protons and neutrons. So for example, a stable nucleus is carbon 12, and it has 6 of each, 6 protons and 6 neutrons.